I'm often asked why there are two different ways of doing simultaneous equations. Why are these simultaneous equations? Well, that's for another video, but we're trying to find out what x and what y are. And there's two different approaches. There is the substitution approach, what's called the substitution approach, often. And there's also the difference approach. The difference approach is where you basically just take one away from the other. I'm not going to do that straight away. I'm going to first do the substitution approach. I think it will be better if we just learn the substitution approach. Why do I say that? Because the difference approach can be used later on at a higher level if you're doing computer programming, or you are doing engineering, or you're doing some other kind of application of maths where that is a handy way of solving simultaneous equations. But the substitution approach, which is what we're going to do first, is the kind of universal approach that will basically kind of solve pretty much any simultaneous equation. I'm talking in generalizations here, so please be nice in the comments. Okay, so how do we do a substitution? What we do is we say, well, I know that x and y mean the same thing in both equations, so what about if, why don't we call that equation number 1, call that equation number 2, let's rearrange equation number 2. So we'll take equation number 2 and we'll make that so it becomes y equals 7 minus x. Should we call that equation number 3? Let's go for it. What if we put number 3 into equation number 1? Okay, so let's write this out. So we then end up with 3x minus 2 times 7 minus x equals 11. Does this look weird? Possibly. What have I done? That is y. Otherwise, can you see it's exactly the same as the first equation? It's just 3x minus 2 times y, 7 minus x, which is equal to 11. So why do we know? How can we know that y is the same as 7 minus x? Because we worked it out here, and that came from the second equation. Okay, breathe. Hopefully that makes sense. So now I can just expand this out. 3x minus 14. Right, minus times minus is a plus, plus 2x. By the way, if this is a bit weird, I've got some playlists and things on my website which will explain substitution a lot more, and there's a really nice playlist which will take you from basically not doing simultaneous equations to doing simultaneous equations. Anyway, the point of this is it's slightly higher level and it's explaining the difference. So let's now finish this off. So then 5x minus 14 equals 11. Minus, add 14 to both sides, so 5x equals 25. Divide both sides by 5, so x equals 5. There we go, so we've worked out what x is. Now we substitute that back in. We know that x plus y equals 7. Therefore x plus 5 equals 7. So that means that x equals 2. Oh my goodness, I made a terrible mistake here. What's gone wrong? Oh, I know what I've done wrong. What I should have said was 2, let me start again, 5 plus y equals 7, so y equals 2. There we go, just keeping you on your toes. So y is 2 and x is 5. That's called substitution, because you just put one equation in the other. Again, if that's a bit too fast, this is kind of an overview video where we're just kind of looking at both ideas and comparing them. The difference approach is the one that a lot of people are more familiar with. So let's take this equation and times it by 2. So that then creates 2x plus 2y equals 14. And then we want to minus 1 from the other. No, we're going to add them together, because if we add, I'll do what I see a lot of people do. I'm going to rewrite the first one. So I've just rewritten the first one. That's where that's come from. I can now add those two together. 2x plus 3x is 5x. 2y minus 2y, well, that just disappears. 14 plus 11 is 25. Oh look, so that means that x equals 5. I'll try not to make the same mistake I did last time. That means that x plus y equals 7. We already know that. We can put x equals 5 into there. So 5 plus y equals 7. So y equals 2. Do you agree that's easier? Probably. It is easier because you've probably done it a few times at school or wherever you're learning maths, and so you're kind of comfortable with it. It kind of makes sense. Is it useful? Yes and no. It's only useful if they're like linear, or at least if you've got like two things that can cancel. Because if that had been a squared and that had been a squared, and that had been, then you could kind of do the same thing-ish, but you'd have to then do other things at the same time. But anyway, so they kind of need to be the same. I'm not saying it can't be squared, but you have to have exactly the same things, because otherwise you can't like take them away and cancel them and stuff. Okay, is the other one slightly more difficult? Yes, it is. Is it useful? Well, this one I think we can just say it is useful. Full stop. No ifs, no buts. Any simultaneous equation, you can do it like this. If I'm teaching someone from scratch, for whatever reason they're being home taught and I'm helping them, or they're retaking or something, I tend to just teach the substitution method. And the substitution method I know does make sense, and then depending on the time issues and stuff, we don't even bother doing the other method. So I've seen it work on its own. Do I think, I mean, if you want my personal opinion, hey, the difference method is useful. You know, there's more than one way to bake a cake, or I can't quite remember what the phrase is. So it's fine. We could do the difference method as well. It's all fine.